Problem 8.38 entails a variable that has a normal distribution. So this is our favorite continuous probability distribution. As we explained before, it's the most widely used in industry, so in the practice and in research. So we are given that a long-distance calls made by employees of a certain company are normally distributed with a mean of 6.3 minutes and standard deviation of 2.2 minutes. So obviously we're talking about the time, okay, of the calls. And we want to find the probability that a call lasts between, in the first part, lasts between 5 and 10 minutes. Okay, so in order to make my probability statement easy, let me first define x to be the long distance call time in minutes. I have to specify that. Okay. So what do I know about x? We are told that x is normally distributed, and we know that a normal distribution has two parameters, mu and sigma. These should be known usually from historical data. So specifically, I can denote x as being normally distributed. I know the mean is 6.3, standard deviation of 2.2. So I describe now the probability distribution of x. Now let me put it on the curve, and here we go. So we have a normal curve, which is the bell-shaped curve, very, very nice curve, symmetrical with respect to the mean, 6.3, which means the area to the left-hand side of the mean, okay, is 50%, and the area here is also 50%, and the area under the whole curve is equal to 1. Okay, now let's see, what are we asking for? We need to find the probability that x is between 5 and 10, right? So we want to find that area, that probability. So let's see how this probability is translated into an area under the curve. So between 10 and 5, here is 10, here is 5. So we're looking for this hashed area, right? Let's call it A1 for now. So which means that the probability that x is between 5 and 10 is simply that area A1. Okay, now this area, I cannot read it yet from the z-table because the z-table gives me the probability that z is less or equal than a certain value. What does that mean? That means if this is the z curve, okay, so what I read in the table are areas, right? But these areas are all the way from that, from the end, which I will call the lower tail, until a certain value, a critical value or a boundary or whatever you want to call it. Okay, so you can see that A1 does not satisfy this condition. A1 is between two boundaries. It's not from that lower tail yet. Okay, so what I can do, I will find then A1 in terms of different other areas. So I say that A1 is equal to a big A, which is from the lower tail until 10. So let me do this without ruining the curve completely. Here we go. It's all that area, okay, minus the area from the lower tail to 5, so which is this one, minus A2. Okay, now this will help me a lot because now I can find that big area and A2 because they satisfy the condition that I just explained on the top. So let me first clean this up so that you don't get confused. Okay. Okay, here we go. And let me take out this and these. Okay. All right. So the big area, it's P of x less or equal than 10, right? It's all the way, it's the cumulative. So as we learned in the lessons videos, that now I want to standardize so that I can read from the z-table. So what I do, here I have an inequality, right? So I will subtract mu and from on the left hand side and on the right hand side, and then I divide by sigma on the left hand side and the right hand side. So I will end up with this. So it's x minus mu over sigma. On the right hand side I have a 10. So instead of mu I type the exact value of mu divided by sigma. Now this is what? This is z. So this is why now I have a z term here. And the right hand side of the inequality, now it's a value. It's 1.68. So what do I do now? Once you reach such a probability expression or statement, we are lucky because we can read that from the z table, right? Because the z table gives us for any z value the cumulative area under the curve. Here we go. So this is an extract of the z table. We look for z of 1.68. Okay, so this is 1.6. And then we go to the column which is 0.08, so that when we add to it, it will become 1.68. The 0.08 column is the last one, okay, that I'm showing here in my extract. So to find the area, to find the corresponding area of 1.68, here we go. So it's 0.9535. So I will note it down. Okay, so that's the big area. Now we want to find A2. A2, I will do exactly the same. Let me first clean it up a little bit so that again things will be clear for you. All right, and maybe this. Okay, so we did exactly the same procedure. We are standardizing x, so we subtracted mu and we divided by sigma the two terms. Here we go. So now we have a probability statement in z terms, less than minus 0.59. So now you look in the first page of the z table. So I'm taking an extract that includes that z value. So we have z minus 0.59. Okay, so that's minus 0.5. And then the last column corresponds to 0.09. So when I add it to minus 0.5, it will give me minus 0.59. So I read the area on the last curve, the intersection with that row, the row corresponding to minus 0.5. So here we go, 0.2776. So I noted down. All right, that was hopefully clear for you. Now we are finally able to find the area that we are looking for. So the probability that x is between 5 and 10, I subtract the big area and or the small area from the big area, and we get 0.6759. Okay, we're going to answer two more questions in this problem. In part B of this problem, the question is to find the probability that the time will last more than, or the call will last more than 7 minutes. Okay, so something that maybe I mentioned before, in all probabilities where we have the PDF, it helps a lot to visualize the area or the probability that we're looking for. So let's see that in the PDF that we have. So we are asking for time to be beyond 7, right? So this is 7. So in fact, we are looking for this area, okay, A2. So now in probability expression, we can write that P of x greater than 7 is equal to A2. But as also we mentioned in the previous slide, A2 is an area that I cannot directly read in the table. Why? Again, because the table gives us the areas from the lower tail until a certain boundary. But this is not a big deal, because what I can do, if I want to find A2, what I can do, I can find A1, which is this one, right? Because I know the relationship between A2 and A1. A2 is Let me clean this a little bit, it's bothering me. Okay, here we go. So I know the relationship between A2 and A1, right? We know that the area under the curve is 1. So since we can see that A2 and A1 complement each other, that means A2 is 1 minus A1 or A1 is 1 minus A2. Okay, so now I can, what do I know about A1? I can express that in a probability statement. A1 is probability that x is less or equal than 7, right? This is all the range of x, okay, for which A1 represents. So, and this is something that I like because it's a cumulative from the lower tail, which is, I can read it in the table. All right, so this is now a relationship between the two probability statements. P of x greater than 7 is 1 minus P of x less or equal than 7. You're going to use that a lot in your life. All right, so if you are told or you are asked to find the probability that x is greater than a certain value, all what you have to do, you say, all right, so this will be equal to 1 minus probability that x is less than that value, and then you deal with this part of x less than that value as we did so many times now by standardizing it, reading it from the z table, and then find the area and subtract it from 1. Okay, very simple. So let's find P of x less or equal than 7, standardizing it. Okay, I'm not going to repeat this procedure anymore because you should be familiar with it now. So it's P of z less or equal than 0.32. And we know that this is something that we can read easily on the z table. Here we go. 0.32. You want to try to find it yourself. This is 0.3. And this is the column 0.02, which means 0.32. Here we go. Okay, so that's equal to 0.6255. Now this is not our final answer yet, right? This is A1, as you can see on the right hand side under the curve. It's equal to A1, but what we are looking for is A2, right? Because the question is find P of x greater or equal than 7. So P of x greater or equal than 7 is 1 minus what we just found. So here we go. This is our final answer. Okay, there's one more question that we want to answer next. All right, last question. Here we want to find the probability that the long distance call time lasts less than 4 minutes. Okay, so let's locate that in the curve. Here we go. So we're looking for this area A3. Okay, so we can then write that P of x less or equal than 4 is A3. This is very clear for us, right, under the curve. So guess what? What would be our next step? Think about it. Yes, we're going to standardize. So P of x less or equal than 4. Again, we do the standardizing procedure and we end up with this one. Now we look in the z table. Minus 1.05, okay, so that's minus 1.0 here, and the first column corresponds to 0.0, and then 0.1, 0.2, 0.3, 0.4, 0.5, so I'm in this column, minus 1.05, so this will be the area I'm looking for, A3. And here we go. Okay, so I hope that this problem was clear for you. We have answered all kind of questions that you can have when a variable has a normal distribution, and you will be ready now to answer any question that you are asked to answer.